Welcome back after the ad break. Let's continue with geomophology. The questions that follow now is the questions that we discussed, the type of runoff that we experience in rivers. Now the first question that we see over here, there's three important things that should be present for water to infiltrate in the soil. Now can you remember we looked at surface runoff and groundwater runoff. Now to experience infiltration, and that means groundwater runoff, what needs to take place? The rock needs to be permeable, allow the water to infiltrate. Now if we look at another factor, if the area is covered with a lot of vegetation, is it going to promote infiltration or is it going to promote surface runoff? It's definitely going to promote infiltration. So if it's covered with a lot of vegetation, the water will rather infiltrate in the soil. And last but not least is the steepness of the gradient. If it's a flat gradient, the water is rather going to infiltrate. When it's a steep gradient, it's going to promote surface runoff. Now, if you look at the next question, describe how groundwater supplies are replenished, filled up. Now, it's usually by precipitation. If an area receives more rainfall, the chances are that the groundwater is going to be filled up much quicker. So definitely our answer can be precipitation, rainfall. If we look at our third question, why is it important to look after groundwater? Now the simple reason for that, Gr12, is South Africa is quite a dry country. We need every single drop of water. And especially if we haven't received a lot of rainfall and our rivers are empty, we can at least rely on our groundwater resources by using boreholes. Now, if you look at the next question, refer to drainage basin A and B in figure 2.2.C and the flow hydrograph showing the line graphs D and E after a period of rainfall. Now, let's just quickly look at these two diagrams over here. Now, first of all, will you agree with me that A is a trellis pattern and B is a dendritic pattern? How do I know this? Joins at acute right angles, and if you look at B, resembles the branches of a tree. And as you can see, now just by looking at that, I can guarantee you that if you look at your hydrograph, E represents diagram B and D represents diagram A. So let's just quickly look at the questions that follows. Now the first question states, the rivers in drainage basin A flow all year round. What type of rivers would this be classified as? Now can you remember, this year we've learned about permanent rivers, exotic rivers and periodic rivers. So if we look at drainage basin A, it's a solid blue line. It's definitely going to be a permanent river. Now graph D in the flow hydrograph shows the runoff of drainage basin A after a period of rain. Define the term lag time. Now we looked at our hydrograph. Lag time is when peak flow is being reached, when most of the amount of rain has fallen. Now, how would the lag time change if massive deforestation were to occur in drainage basin A, where D was recorded? Very simple. Now, deforestation is removing the vegetation. So what's going to happen? Is the water going to have any chance to infiltrate? No. They won't be able to infiltrate, there won't be time. So what will happen? There's less vegetation, so there's going to be more surface runoff. Justify your answer. Because of the deforestation taking place, water won't be able to infiltrate and there's going to be more surface runoff. Now, the next question, name any other factor which could have occurred and have the same impact on the lag time as mentioned in question B. And the answer to that question will be change in rainfall, heavy rainfall, or a very steep slope, or the permeability of the rock. So any one of those factors will also shorten the lag time. Now state the drainage density of the drainage basin B. If you look at that, it's definitely a high drainage density. If you look at drainage basin B, it's the one with the dendritic pattern. Now as you can see, there is many tributaries, and that means there's a lot of surface runoff taking place. Now if you look at question number B, describe 3 possible causes for the drainage density found in drainage basin A. Once again, the factors that influence the runoff: a steep slope, higher rainfall, less vegetation, and the permeability of the rock. It might be impermeable, it doesn't allow water to infiltrate, so it's going to promote surface runoff. And that's the reason we can see so many tributaries joining the main stream. Now, our next question: identify and briefly describe the drainage patterns in figure 2.2.3G. Now, it's quite easy to identify them, and we discussed them. Very importantly, not only in your theory paper, but in your mathbook paper, you need to be able to identify these different drainage patterns. Now, first of all, before we're looking at the answers, A resembles branches of a tree. That is dendritic. If you look at B, usually parallel with one another, and they join at 90-degree angles, as you can see over there. That's your trellis pattern. And then, as you can see, it's flowing outwards. That's your radial pattern. Now, let's just quickly look at the questions that follow. Now, the question states, how do we know this is a dendritic pattern? Now, first of all, it resembles the branches of a tree, and what can we say about the underlying rock? Is uniform resistance to erosion. So it means the reason why they look very much the same is because the underlying rock is the same. If you look at the trellis pattern, the rock is not the same. There's rocks that can erode much faster than the underlying rock. And if you look at the radial pattern, it's usually happening from a high-lying area moving downwards in different directions. Now, our next question over here: draw a longitudinal profile of a river from the source to the mouth and show the upper, middle, and lower course. Now, when we discuss the river profile, we know that the river originates from the source, and where we experience base level of erosion, that's where the mouth is. So there's the source, there's the mouth. Now what we can do with this river profile, we can divide it up into the upper, middle, and lower course. Now, what do we know about each of these courses, characteristics of them? The upper course is where the source of the river is. So the volume of water is not as great as in the middle course, because what happens in the middle course? Other rivers start to join this main river, so the volume of water is going to be increasing. Now list 2 features of the upper course of a river. Now what do we know? Look at the gradient, it's extremely steep. So it's got definitely lateral erosion taking place. And what we find over there? Waterfalls and rapids. So I just gave you actually 3 features over there. Now if you look at our next question, describe a river in its lower course. Now can you remember when we discussed the river profile? Lateral erosion taking place over there, lateral and vertical erosion taking place. If you look at the river bed, it's getting deeper and wider. But what happens at the lower course? We experience deposition. All of the material that's being eroded are being deposited over there. So if you look at features that form at the lower course, the river starts to meander, well-developed floodplains, stream grading can take place, and the increase of volume of water has increased. If we quickly look at question number 4, describe one difference between the river channel in the upper course and in the lower course. Now the river channel over there is very narrow and deep, where the river course is very wide and shallow during the lower stages of the river. Now let's quickly look at the questions that follow. If you look at figure 2.2.5k, shows a plan view of an area before river capture has occurred. Now let's move back to this term river capture. When we discussed this, is when one river steals a river from another. It's when one river steals water from another river. We also call it stream piracy. Now, the question in your workbook asks, redraw the rivers after river capture has taken place. On the diagram, you have drawn, labeled the resultant features of river captures. Now what they basically ask you, now what do we know? If you look at this diagram over here, River A is at a lower altitude. River A has got greater volume of water, and River A might be flowing on less resistant type of rock. River B is an area that receives less rainfall. River B is at a higher altitude. Now, just by looking at the two, I'm just going to increase this line to show that River A consists of more water. Because of River A's velocity is greater because of the volume of water and because of a steeper gradient, headward erosion is taking place. Now, what we've learned so far, a watershed separates one drainage basin from another. Headward erosion takes place. What does River A do? It erodes through the watershed and starts stealing the water from River B. Now, what do we call this? Now, they asked to redraw the diagram, and what do we call River A? Is the pirate stream. B is the captive stream. If we look at this area over here, where the interception took place, is the stream elbow. Now, immediately where the water has been intercepted, we will have a dried up area, and that is known as the wind gap. And this will be known as the misfit stream. So basically, we just answered your question. Redraw the rivers after river capture has occurred. On the diagram we have drawn and labeled the resultant features. Now, as you can see, because of headward erosion through the watershed, River A stole the water from River B. That was the captive stream, the pirate stream. Where the water has been intercepted is the stream elbow, and where it's going to completely dry up is known as the wind gap, and the rest of the stream where it continues is known as the misfit stream. Now, our next questions that we're going to have a look at focus on settlement issues. Now, if you quickly look at the next question, complete a table to illustrate your understanding of the classifications of settlement as either rural or urban. Now, we discussed this before. What's the function in rural areas? It's usually unifunctional. It's only one activity taking place. In most of the case, what type of activity is going to take place? It's going to be primary activities. If you look at urban areas, it's unifunctional, multifunctional, and it's usually where secondary and tertiary activities take place. So if you look at the function with rural areas, you can usually say it's unifunctional. It's usually primary activities taking place. When we look at urban areas, it's usually multifunctional, and it's where secondary plus tertiary activities takes place. Okay, now if we look at the size and complexity, we looked at that in our previous activity. Now when we look at sizes and complexity of rural areas, it's usually very small areas. There's only a small amount of people living together. Now if we look at a settlement, if we want to define a settlement as where people live. Now if we look at size and complexity, it's usually farmsteads, villages, and hamlets. Now if you look at urban settlements, it starts from towns, include cities, metropolis, conurbations, and a megapolis. So that's the difference between your rural and urban areas. Now keep in mind, very importantly, rural areas is not informal settlements. Rural areas is where primary activities taking place. For instance, farming, fishing, or mining. And urban areas is usually where secondary activities takes place, such as manufacturing, processing, tertiary activities, for instance, service delivery like schools and hospitals. Size and complexity, now obviously they are being classified according to their size. The smallest is your rural settlements, a bunch of farmsteads or hamlets together, and urban settlements stretch from urban areas like towns to cities to conurbations. After the break, we'll continue with our revision exercises.